All right, so my name is Alan Leibovitz. I'm the Associate Dean for Math here, and I'll be conducting the College Algebra Review. So there was already a request to go over some exponential function and logarithm topics. So a problem like this, say, solve for x. 2 to the x plus 5 equals 3 to the 2x, something like that.
Take away the x. There's only x on one.
Oh, you want just x on one side?
Yeah.
Do you want the x plus 5?
Huh?
Do you want the plus 5 or just an
the
x?
2x, because I just want one x on one side and
Okay.
none on the other.
All right, because we cannot write 2 as 3 to a power or 3 as 2 to a power, then the only way to solve this is with logarithms. So you need to take the log of both sides. I like natural logs, so that's what I'm going to do. So it's the natural log of 2 to the x plus 5 equals the natural log of 3. Then, property of logarithms, once you take the log, the exponent comes down front as a coefficient, but it has to be in parentheses. Now from here, we have to apply basic algebra strategies, which are everything with an x needs to be on one side, everything without an x needs to be on the other. It's that simple. So what are we going to do here on the right-hand side? What? We're going to distribute. So we get x natural log of 2 plus 5 natural log of 2 equals the natural log of 3. Now what?
Subtract 5 natural log of 2.
Subtract the 5 natural log of 2. Now these are not like terms. There's nothing you can combine. You're just going to write it. So you get x natural log of 2 is the natural log of 3 minus 5 natural log of 2. And we have x times something, so to solve, we divide by that something. So you get x is equal to the natural log of 3 minus 5 natural log of 2 over the natural log of 2.
What if, instead of x plus
Well,
5?
hold on. Let's finish and then we'll try some other permutations. Now, if you have to get an approximation, if you have to put this in the calculator, this is very complicated to put in the calculator. What I recommend you do is you use properties of logarithms to try to simplify that numerator. Otherwise, it's very likely you're going to put it in the calculator, you're not going to have enough parentheses in the right place, and you're going to mess up the answer. All right? So let's just look at that numerator. The natural log of 3 minus 5 natural log of 2. How do we write that as a single logarithm?
Divide. Divide.
What do you mean divide them?
When you subtract them.
Well, I can't do that yet because I have a coefficient.
Oh, yes.
All right, so the coefficient has to come up as an exponent first. So this is the natural log of 3 minus the natural log of 2 to the 5th. Then change the subtraction of logs into division. So this is the natural log of 3 over 2 to the 5th. All right, remember all I'm doing here is a to the natural log of b is equal to the natural log of b to the a. And then to get from here to here, I'm using the natural log of a minus the natural log of b is equal to the natural log of a over b. So now that I have that, 2 to the 5th is 32. So then the answer is the natural log of 3 over 32 over the natural log of 2. And that's pretty easy to plug into the calculator. All right, you can just plug in one, plug in the other, and then divide. This is a lot more complicated on the calculator. Okay? Questions on what's up there? All right, what was your other question?
I was saying, if you put like a 3 next to the x, so now instead of x natural log of 2, it becomes 3x natural log of 2. You see how it's 2 and then the x.
Okay, so in other words, if there's a 3 here.
Yeah.
Okay, that would put a 3 here. That would put a 3 here. That would put a 3 here. That would put a 3 here.
And do you divide?
Well, all right, hold on, okay.
Okay.
Here, how many things am I multiplying? Right here, 3x natural log of 2. How many things are being multiplied? 3. The 3, the x, and the natural log of 2. So if I'm going to divide, I don't have to divide by one thing, I can divide by multiple things. So I would just divide by that 3 natural log of 2. Just like if, let's say I was solve for x, and the answer, and I had abx equals 1. I can divide by a times b, right? I think what messes you up here is the order. The fact that you're solving for x and it's in the middle.
Yeah.
So you're viewing these as separate things. Well, if I had solved for x and it was ax times b equals 1, it'd be the same thing. You divide by ab, they're still going to cancel no matter what you did.
Okay. So then it'll just be 3 natural log of 2.
You would have the 3 natural log of 2, which then this would become natural log of 8. Because you bring the 3 up,
Okay.
right?
Yeah.
Just like I simplified the numerator, I would simplify the denominator, right? 3 comes up as 2 to the 3rd,
Okay.
is 8. Right, so it looks scarier, but there's no change to the algebra whatsoever. Yes?
I was told that you could just factor the x out and put everything else in parentheses and that makes it easier.
If you have 2 different x's. In this case, we didn't have 2 x's. That would be if you had, there's a copy of the review. If you had an x on one side and an x on the other. All right, let me go ahead and do one of those. And I'm trying to keep the problem as simple as possible here. So 2 to the x plus 3 equals 5 to the x. So again, we would take the natural log of both sides. Or the common log, right? LOG common log, doesn't matter. The exponents come down. Remember, the binomials have to be in parentheses. That's a very common mistake, is to bring this down and not have it in parentheses. Oops. X natural log of 5. Then we distribute. That's the same. That hasn't changed. So now we'll talk again about basic algebra strategies. You want your variables on one side, or your terms with the variables on one side, and the terms without the variables on the other side. So that means we want all of our x terms together and all of our non-x terms together on the other side. Well, what's the best way to accomplish that?
Subtract x natural log of 2.
Move the x natural log of 2 over to the right. That's the most efficient way to get the x's on one side, numbers on the other. So if we subtract the x natural log of 2, we get 3 natural log of 2 is x natural log of 5 minus x natural log of 2. Now at this point, these are not like terms, so we can't subtract them. The only way to simplify that is what you alluded to, is to factor out the x from the right-hand side. That's the trick. You have to know the trick. So we get 3 natural log of 2 equals x, and when we factor the x out, we get natural log of 5 minus natural log of 2. Now in this case, again, we had x times something, We solve for x by dividing by that something. So we get x is 3 natural log of 2 over natural log of 5 minus the natural log of 2. And if you want to simplify that as much as you can bring the 3 up. It becomes the natural log of 2 to the 3rd, which is 8. Here you can combine using the same property before. Subtraction of logarithms becomes the log of a quotient. So this becomes the natural log of 5 halves, or 2.5. Are there any other exponential or log questions that you guys have from any materials that you have? Anything that I've handed out? I understand that this is one of the last things you do in college algebra, and it's probably the toughest thing you do in a college algebra class. Yes?
Will we have time to go through all of them?
In 2 hours, I can do them all. Whether I can teach them all is up to you. But let's focus again on logarithms, because I know that's what you guys have done most recently. It's the hardest. And then we can do anything else you guys want. Yes?
Yeah, inequalities, the determining inequality, the absolute inequality.
Okay, absolute value or quadratic or rational inequalities, all of them, or just the absolute value?
Let's do all of them.
Okay. All right, I'll tell you what, I'll make a list. All right. And we'll come back. All right, but anything else on logarithms or exponential functions, applications of exponential functions, compound interest, any of that stuff?
Number 15.
Okay, that's composite functions. I'll come back to that.
Domain and range.
Okay, domain and range.
Yeah.
There's a review over there on the table. All right, let's go ahead and get started. Not in the middle, please. We're filming. All right, so I've got some quadratic, absolute value, and rational inequalities. All right, let's start with an absolute value one. The absolute value of x minus 2 is less than 3. Okay, this is on the review number 5. On the review number 5. Now, what does absolute value mean? If you understand what absolute value means, these problems become a lot easier. What does absolute value mean?
Distance away from 0.
Distance from 0. Now, so the distance from 0 of x minus 2 is less than 3. All right? Now, whenever you have less than, your distance from a certain point is less than a certain amount. The way I like to visualize this is a dog on a leash staked into a yard. All right? But the dog can't go in a circle. So the dog can go so far in one direction, and it can go so far in the other direction. Where that stake is 0. Right? So their distance from the stake is less than whatever the length of the rope is. Okay, chain, whatever it is. So they can go from one end to the other, and where else? Anywhere in between. So they're between one extreme one way and one extreme the other way. Okay, that's the visual. So if the absolute value or distance from 0 is less than 3, let's say your distance from 0 is exactly 3. where are you on the number line? Where could you be? If your distance from 0 is exactly 3 units, where are you on the number line?
3.
You're at 3, or
Negative.
you're at -3. Now, if your distance is somewhat less than 0, where could you be? Somewhere in between, but not including -3 to 3. So we're somewhere in here. Now, that's not the answer. What that is how to set up the problem. That's the key. So what we're taking the absolute value of is between -3 and 3. So what we're taking the absolute value of is between -3 and 3. Right? So -3 is less than or equal to x minus 2, which is less than 3. Whenever you write a compound inequality like this, the inequalities have to go the same direction. If they're going in different directions, it's wrong. Flat out wrong. All right, so now that we've set it up, this is pretty easy. We need to add 2 to the middle in order to solve, so we do that to the extremes. And we get -1 is less than x, which is less than 5. So the interval notation, because these are not equal to, it's going to be parentheses, and then from -1 to 5. Okay? Now, let's do a slightly different one. Let's say we want to solve the absolute value of x plus 1 is greater than or equal to 4. Now, for this one, I have a different analogy. Your distance from 0 is greater than or equal to a certain amount. This is my bodyguard example, or a restraining order example, right? That x plus 1 has to stay at least 4 units away from 0, or the bodyguards are going to get involved, okay? So, again, if you are exactly 4 units from 0, where are you on the number line?
4.
At 4 or -4. Now, if you're more than 4 units from 0, greater than or equal to, where are you? Are you closer to 0, or are you further away from 0 than 4 and
The
-4?
2 ends.
You're further away, so you're at the 2 ends. Now, in this case, we are including the endpoints because of the equal. Now, again, understanding this picture tells you how to set up the inequality. So here, we know that x plus 1 is in either of the shaded regions. So we know that x plus 1 is greater than 4, or x plus 1 is, or excuse me, greater than or equal to 4, or x plus 1 is less than or equal to -4. You know what, let me write each inequality near the segment on the graph. Now these are easy to solve. Subtract the 1, so x is less than or equal to -5. Subtract the 1, so x is greater than or equal to 3. So here, you have to write the interval notation. Now you may want to graph that to make sure you're okay with it, right? Depends on your comfort level. So we've got -5, we have 3, inclusive. So we're going to have a bracket and then less than -5, a bracket greater than 3. And then from there, the solution is -infinity to -5, inclusive, then union. Remember, whenever you have those two separate pieces, you need the union. And then inclusive 3 to infinity. And remember that we always have parentheses on the infinities, the plus and the minus. Now, some of you, I'm sure, can go straight from the inequalities to the interval notation. That's a matter of comfort level for individual students. If you're not comfortable with that, then go ahead and regraph it. And it's a lot easier. Okay? Questions on the absolute value equations and inequalities?
I've had
Yes.
some problem on array where when it's separated like that, it says no solution in the middle. Which questions are there?
Okay, you can get no solution for some of these.
Right.
It depends on the problem. Generally, when you get two kind of funky problems, less than a negative and greater than a negative. So if you want to solve the absolute value of x plus 5 is less than negative 1, or the absolute value of 2x minus 3 is greater, equal there, greater than negative 7. Now these answer themselves without doing any algebra. That's the key. If you do the algebra, you've already lost. We know by definition the absolute value of a quantity is 0 or positive. Okay? So whatever is on the left here, I can substitute with 0 or a positive number. All right? So if I say 0 or a positive number is less than or equal to negative 1, when is that true?
Never.
That's never true. 0 or a negative is, or 0 or a positive is never
Okay, so
less than negative 1,
okay.
so this one is no solution. But this one, if I say 0 or a positive is greater than negative 7, when is 0 or a positive greater than negative 7? That's always true. So everything is a solution. So that's from negative infinity to infinity. Now you can work these out. This one gets funky. Like if you start working this one out, okay? Now I know what some of you have done. Some of you are like, why isn't he talking about the shortcuts? I just want to know about the shortcuts. So for you guys, the shortcut is when you have a less than, you keep this part, and then you just put the opposite number here on the left. Right? How many of you just kind of memorize that procedure? I'm sure there's at least a couple of you. The problem is if you do that here, and you say, okay, this is an x plus 5, and this is less than or equal to negative 1, and then the opposite here is going to be a positive 1. But look at what that says. 1, positive 1, is less than or equal to something which is less than or equal to negative 1. Well, ignore the middle part. What have you just said? That negative 1, or positive 1, is less than or equal to negative 1. That's false. All right? It's what we call a math contradiction. But the problem is you'll go ahead and solve that because you've just memorized a procedure without thinking about the consequences of that procedure. Now this one, if you work out, what happens is instead of getting a graph that's the right number to the right and the left number to the left, it switches.
Okay.
You get one the left number to the right and the left number, or the right number to the left. And you end up shading the whole number line.
So basically what you're saying, that in the absolute value line, if it's a negative inside of there, then it's infinity.
Well, now, hold on. See, you're trying to memorize.
No, I'm not trying.
And no, yes you are. You're trying to memorize, you're not thinking. If the absolute value, doesn't matter what's on the inside.
Mhm.
The inside doesn't
It's
matter.
always wrong.
If the absolute value is less than a negative,
Right,
there is no solution to that equation because it never happens.
right.
If the absolute value is greater than a negative,
Okay.
that always happens.
Okay,
All right? So it's all real numbers.
okay, so it has to be the greater or negative, less than sign. Okay.
With, right, that's what you're looking at.
Right, okay.
Okay? Any further questions on absolute value inequalities? No? All right, let's do a polynomial one. This is number 4 on the review. solve x squared plus 5x minus 6 is greater than 0. Now there are a few different ways to do this depending on how you've been taught. The most important thing here is you have to factor that no matter what. So we need two numbers that multiply to -6 and add to 5. It's going to be +6 and -1. So we need what are called critical numbers. That's actually a calculus phrase. So if we set this equal to 0, you get x plus 6 is 0, x minus 1 is 0, so x is equal to -6 or +1. All right, those are the critical numbers. So then we're going to do a little number line. My recommendation with the number line is only put the numbers that you need. Notice I don't put a 0. Why? Because it has nothing to do with the problem. I'm only putting what I need. So basically, you're going to plug in some test points in each region of the number line. Because we have two critical values, we have 3 regions. And then determine what's going to give us greater than 0. Now, because this is a somewhat simple problem, it's already set up as a polynomial greater than 0. What's another way to say greater than 0? All numbers that are greater than 0 are positive. So when I plug in a number, I really don't care what number I get out. What I care is whether that number is positive or negative. And I can determine whether that number is positive or negative based on if I'm multiplying positives or negatives. Does that make sense? So let's say I'm going to plug in x is -7. So when I plug in -7, I'm going to get a -1 and a -8. Now, yes, I know that -1 times -8 is 8. But really, all I care about is a negative times a negative is positive. A number between -6 and 1, how about 0? When I plug in 0, I get 6 times -1, and that's going to be negative. Then when I plug in a number greater than 1, how about 2? I'm going to get 8 times 1, which is positive. So remember, I was solving for greater than 0. Greater than 0 means positive. If this was less than 0, then I would want negatives. Now I could have easily just worked this out. Okay, here I get +8, here I get -6, here I get +8. Right? That is the same thing. So then these two pieces here on the ends is really what I'm looking for. So this is -infinity to -6, non-inclusive because it's not equal to, right? These would be non-inclusive critical values. Union 1 to infinity. Now, there's a slightly different way to do this. Depends on how well you understand the graph for a function like this. Okay? This is what kind of equation? It's quadratic. What does the graph of a quadratic equation look like?
Parabola.
It's a parabola. Okay? Which way does this parabola open?
Up. So it's up.
It opens up, okay, because it's a positive x squared. So the graph of this, we already know what the x-intercepts are. Because to find the x-intercepts, you set the function equal to 0 and solve. So I know the x-intercepts are -6, 1. And we know the graph is going to open up. It's a parabola, so it's going to do something like this. Super accuracy here is not important. Now, where are the positive regions on this graph? Where are the positive regions?
Above X.
above the x-axis. So that's this piece and this piece. So where are those? To the left of -6 and to the right of 1. And that's the answer. Remember, more than likely, is everyone having a multiple choice exam?
No.
Not
You're having a mixture?
Yes.
Okay. Well, then you have to go ahead and show your work.
Yeah.
But for those of you, if this is a multiple choice question, something like this can be very useful. Okay. And for a basic polynomial like this, where it factors nicely, the signs are going to alternate. Right? If you take pre-calculus, the signs don't always alternate. It's a little bit trickier. Yes?
How would you do number 2?
I'll come back to that one. I'll come back to that one. Are there any other questions on this one? All right. Then the rational inequality, let's go ahead and do that one. This is number 6 on the review. Solve 3x plus 2 over x minus 5 is less than or equal to 0. All right, so again, this problem is fairly straightforward. First of all, you have to make sure that the inequality is compared to 0. That's important. So we need to know the critical values. The critical values are where the fraction is 0 and when the denominator is 0. And the fraction is 0 when the numerator is 0. So this one's fairly straightforward. We set the denominator equal to 0 and we set the numerator, the numerator equal to 0 and the denominator equal to 0. So this one we get x is -2/3. This one we get x is 5. So we'll plug in, say x is -1, something less than -2/3. When we do that, we get 3 times -1 plus 2 over -1 minus 5. That's -3 plus 2 is -1. It's going to be positive 1/6. So that's a plus. Because it's -1 over -6. If we plug in 0, that one's a lot easier. We get, let me write these in green so I'm not confused. It's -2/5. So we know that's negative. And when we plug in something bigger than 5, say x is 6, we get 3 times 6 plus 2 over 6 minus 5 is actually 20 over 1, so we get 20. So this is a plus. So less than or equal to 0, that's going to be the middle section. But this one's a little trickier. Because of the equals, that means we can probably include the endpoints, but in this case, not all of them. We can include the -2/3 because that makes the numerator 0, which means the fraction is 0. Can we include the 5 in the solution? No, because it makes the denominator 0, and division by 0 is undefined. You can never have a 0 in the denominator. It's not in the domain. So this one is not inclusive. Now with the polynomial, you didn't have to worry about that. Because if it had an equals, you're going to include your endpoints. If you don't have an equals, you're not going to include your endpoints. With the rational, the fraction, it's a little tougher, right? You really have to pay attention to it. So the middle region here is inclusive, -2/3 to 5, non-inclusive.
You wouldn't do the negative infinity.
Why?
No.
Well, again, where's my solution region? Less than 0, it's right here. Right, so whatever region or regions you get on the number line, then you have to write the interval for that region or regions. In this case, it's in the middle, there is no infinity. Okay? All right, so there was a question on a polynomial equation. Number 2. So solve 8x to the 4th minus 18x cubed minus 5x squared equals 0. So what is the first step in solving any type of polynomial equation?
Take out the common factor.
Factor it, and the first step in factoring is take out the greatest common factor. So looking at that, what's the greatest common factor? It's going to be x squared. So you take out the x squared, you're left with 8x squared minus 13x minus 5 equals 0.
What's 18?
Or 18, thank you. So this is quadratic. Now again, a little bit of advice here. If you're taking a multiple choice test, look at the answers. If all of the answers are integers or fractions, that means it will factor. All right, so if your solution sets have a 5, 2/3, 4/5, something like that, they're going to factor. If they have radicals or i's, that means it's not going to factor, and you're going to need to use either completing the square or the quadratic formula. Now, if your teacher gives you a mixture of those types of answers, then you have to figure it out. Now, if you're unsure if it factors or not, go ahead and use the quadratic formula, because that will always work. And if it would have factored, then you're going to get integers or rational numbers, fractions at the end. Okay? So this one will factor. Let's see, we'll do a little guess and check here. Let's try a 2x and a 4x. Yep, so minus 5 plus 1 equals 0. Trust me, right? Something I'm good at. And again, I can, because once I put those numbers down, first of all, the 5 only factors one way, 1 and 5. So there are only so many combinations here. And I did the quick check in my head. Positive 2 here, 2 times 1, and negative 5 times 4 is negative 20. Combine those to give the negative 18. All right? Now, if you need to do splitting the middle term, or you want to use the quadratic formula, do what makes you comfortable. I'm just trying to solve it. So that gives you x squared is 0, 2x minus 5 is 0, or 4x plus 1 is 0. This one you can take the square root. Yes, you get x is 0. Then x is 5 halves, and x is negative 1/4. Depending on your instructor, you may need to write that in a proper solution set, depending on what your instructor wants. Okay? Questions on that? All right, next topic on the list is functions. The question was specifically about composite functions, but we can go over a couple of different things here. Let me give you, this one is number 7 on the review. If f of x is equal to 3x squared minus 2, find f of negative 3. Now this is a fairly simple problem. It's also very easy to get it wrong. So you take the -3, you plug it in. Now what should I write here? Tell me what to write.
3.
Open
Negative 3 squared.
That is correct. If you don't put that negative in parentheses, it's going to cause you all kinds of potential problems, like forgetting to square the negative. But once you get that down, or someone even said 9. If you just know -3 squared is 9 and go from there, then you're golden. You're going to be in good shape. So then this is 25. All right. Composite functions. So f of x is equal to x squared minus x minus 1, and g of x is negative x plus 3.
Which number is that?
This is number 15. Now, the most important thing is to know how to read this. And no, it's not fog of x. All right? This is composition. That is a circle. It's not an O. It's not a dot. It is composition. And when you see this, what does this mean? Composition of functions.
Put G.
You plug one function into the other. Now, the way I like to do this is very slowly, rewriting the notation to make sure you plug the right thing in the right place. So, how do I read this? F of g of x. So I'm going to rewrite that as f of g of x. And then substitute from the inside out. So this is f of g, which is, I'm going to rewrite this. I don't like the way that looks, because I know what's coming. So instead of negative x plus 3, I'm going to call it 3 minus x. Everyone would agree that's the same thing, right? The reason why is, we're going to end up squaring that, and it's a lot easier to square a binomial with the subtraction in the middle. Now at this point, what function are we dealing with? It's a very simple question that a lot of students don't understand. What function are we dealing with? F. Why? How do you know we're dealing with F?
Because you have to put 3 minus x.
No.
Because it says it.
Because it says F. But I've had students over the years, they put the wrong thing into the wrong place. If you just read what's there, that's a lot easier. So f of something, if you have f of something, what do?
That's something plugs into it.
You take the something, you put it in for the variable in f. It's that simple. So this becomes f of something, okay? To me, functions are like a recipe, right? You take this, you mix it with that, you put it in the oven, you do this and whatever. Hopefully it's edible. So f of x says you take, or f of whatever, I like using the word whatever, means you take the whatever, then you square it, then you subtract the whatever, then you subtract the 1. So f of whatever, in this case, is the whatever squared minus the whatever minus 1. Now if you were paying attention, you notice I said the exact same thing up here as I did down here. Because what throws students off is, well, that's an x, but I have an x here and I'm plugging it in and I'm all confused. If you just use the word something or whatever, and if you can say that, no matter what you plug in, you're going to get it correct. So now we've got to square this binomial, and please square it correctly. This is actually 9 minus 6x plus x squared. You can either use the shortcut for squaring a binomial, a squared minus 2ab plus b squared, or you can write it 3 minus x times 3 minus x and distribute. That's up to you. Here, distribute your negative. So this is minus 3 plus x, and then minus 1. So like terms, we have an x squared, we can use that. A negative 6x and a positive x is a minus 5x. And then 9 minus 3 is 6, minus 1 is 5. Now again, the reason why I squared it is, here, we would have had negative x plus 3 squared. And I don't like doing it. There's a review right over there. Right? I never like squaring a binomial when I've got a negative in front. It's like factoring when you have a negative in front. You got to think about it too much. All right? It's a lot easier doing it this way. Now you can have any combination with these. You can have f of f, g of g, g of f, and f of g. Right? You can do these in all kinds of different combinations. You can even do triples. You can do f of g of h. And you just plug one into the next from the inside out. Okay? Now along with that, we can do all kinds of arithmetic with functions. We can add, subtract, multiply, and divide. And then there's domain and range with each of those. So let's say we have, and this is, I'm going to start off with number 20 on the review, and then I'm going to change it up a little bit. So f of x is 3x minus 4, and g of x is 2x plus 3. So let's start with finding g minus f of x. Now this one's fairly simple. What are we going to do? Subtract g minus f. So g minus f of x is really just g of x minus f of x, which is 2x plus 3 minus 3x minus 4 is going to be negative x minus 1. No one's going to correct the mistake?
It's not
Yeah,
correct.
it's plus 4, right?
Why?
Because it's two negatives.
Mm-hmm. That's
Very important here, when you are subtracting functions, put them in parentheses.
So distribute that.
So you distribute the negative correctly. Okay, and for all of you and everyone watching on the internet, I did that on purpose. So this is 2x plus 3 minus 3x plus 4 is going to be negative x plus 7. And that's the correct answer. Now what did I say before? Negative x minus 1? Now if your teacher is good at writing questions, then negative x minus 1 is going to be on there, and it's on the review as a wrong answer. Right? Let's call it the distractor. All right, what if I said, find the domain of f over g of x? All right, what do we need to do here? What's the first thing we should do to find the domain of f over g of x?
See what?
What?
I suppose f over g.
Write the function. Write f over g of x. So f over g is 3x minus 4 over 2x plus 3. Now, for you guys, domain is basically start with all real numbers and then take out the bad stuff. Take out the stuff you're not allowed to have. Now, there are three things you have learned you cannot do in algebra. And only one of them applies to this problem. You can't take the square root of negative, right? Not in the real numbers anyway. So, but that's not involved here. What is something involved in this problem that you know can break a rule in algebra or arithmetic?
Domain of 0.
You can't divide by 0. All right? You cannot divide by 0. So what would happen if the denominator, 2x plus 3, was 0? This would be undefined. And x would end up being negative 3/2. Now, depending on your instructor, there are several different ways to write that. All right, we can just say the domain, say, is x is not equal to 3/2. We can do interval notation, negative infinity to negative 3/2, non-inclusive union, negative 3/2 to infinity. When you take out a single point, that's how you always do it. Right? You're going to have the same number on both sides here, but it's non-inclusive. So that means you're going up to negative 3/2 on both sides. The only thing you're taking out is 3/2. Another way to write that would be the set of x's such that x is not equal to negative 3/2. Have you guys seen this?
No.
All right, this is more familiar to what, like I said, depending on the instructor, you can write a set like this a lot of different ways. All right, any other questions relating to functions? Be it domain, range, composite functions, arithmetic of functions?
On Alex, I really got lost here where the domain, we have like domain of f.
Okay, hold on. Okay,
It's like the domain is in a set, a solution set, and the range is in another set. And we have the x's pointing to the y's, the domains pointing to the y's in relation on Alex.
may I see it? Okay. When I was in college, I had a professor who used to call these the potato problems. So we have function f. 1, 2, 3, or there's no 2. 1, 3, 4, 5, 6, 8, to 3, 6, 7, 9. 1 to 3, 3 to 6, 4 to 9, 5 to 7, 6 to 9, 8 to 6. Now we have G. One, 2, 3, 7, 8, 9. 2, 7. 2, 8. And the problem is find the domain and range of G of f. All right. So remember that the domain is the first set. The range is the second. So the other thing you have to remember is that we're plugging, if we, again, think of this, g of f of x is equal to g of f of x. So the first thing we're doing is we're picking an x in the domain of which function? Which function? It's all right here, of f. Then we're getting an answer from the range. And what are we doing with that answer? We're plugging it into g, okay? So if we had functions here, let's go back to this one. If I had f of g of x, and I find f of g of 7, I would take the 7, I'd plug it into g, I'd get that answer, I'd plug it into f. All right, so we need to see what's going to work all the way through. So let's take a look here. I'm trying to think of different ways we can write this. Now, it's only going to be in the domain if it works all the way through. So the potential domain is this set of numbers here. But not all of them are going to work. So let's see if we can carry something all the way through. All right, so f of x, and g of f of x. We'll make a table. So the f's, we know we can have 1, 3, 4, 5, 6, and 8. Now the f of x, those are right there. So f of 1 is 3, f of 3 is 6, f of 4 is 9, f of 5 is 7, f of 6 is 9, and f of 8 is 6. Okay? So now we're going to find g of f of x, those numbers. All right, so what's g of 3?
7.
Okay, g of 3 is 7. What's f of 6?
There is none.
There isn't one. So this is not defined. What's g of 9?
7.
7. What's g of 7?
7.
7. G of 9 we already did is 7. And g of 6 we already determined was not defined. Now because there's no answer for some of these, we cross them out. And what's left will give us the domain and range of g of f. So in this case, the domain is simply the set of remaining integers. 1, 4, 5, and 6.
Range is 7.
And the range is just 7. Those are curly brackets, by the way. I cannot draw them very well. All right, that's a tricky one, but you really got to write it all out. This is very visual. All right, does it make sense how you would go about it?
Yeah.
Now these are called discrete sets because they're just individual numbers, 1, 2, 3, 4, and so on. So that's kind of the way you would have to do it. If it's more continuous sets, like the real numbers or something like that, then it's a lot more complicated. Okay? Let me give you guys a way different than this, but a tricky domain problem. I used to like to give problems like this when I taught college algebra. Find the domain of f of x is equal to the square root of x over x plus 2. Have you guys done problems like that in your respective classes?
Yeah.
Okay? So in this case, there are different things to worry about. You've got the radical, and you have a denominator. All right, so based on the radical, or 4, say the square root of x, what do we know about x?
Greater than or
X has to be greater than or equal to 0. So that's acceptable. Now, for the denominator, we know the denominator can't be 0. For the denominator, x plus 2 cannot be 0. So x cannot be negative 2. The question is, what's the domain?
You write it in notation.
Okay, and how would I do that?
Parentheses, negative infinity, negative 2, parentheses, union, negative 2, parentheses.
Okay, sure about that? Because remember, x,
Oh, yeah, so it'd just be negative.
remember, x has to be greater than 0.
So I just take away the first part before the union, finish the infinity.
Well, wouldn't that include, say, negative 1? Right? Would negative 1 be in this interval?
Yeah.
And that's not allowed. Okay, let me give you an analogy here. Let's say someone goes into a restaurant, okay? And they say, I would like your best vegetarian dish. And also, I don't want steak. Is that second part necessary? No. So the first part says x must be greater than or equal to 0. So x has to be 0 or positive. And x can't be a negative number. Isn't that redundant? This is the steak in my analogy. Right? You've already said x has to be greater than or equal to 0. So can x even be negative 2? No, you've already excluded that. So your domain,
Are real?
no, it's still
0 to
this restriction.
positive.
Should be parentheses 0 to.
Well, bracket, 0
Oh, yeah, bracket.
to infinity.
Right.
So sometimes, like, this doesn't matter. And that's what threw you off.
Yeah.
All right? Now, what if we change the problem? What if we have g of x is the square root of x over x minus 2? In this case, we again get x must be greater than or equal to 0. But for the denominator, we get x minus 2 can't be 0, so x can't be 2. Now, if x is greater than or equal to 0, just that alone, if x is greater than or equal to 0, is it possible for x to be 2? Hold on. I'm telling you, okay, if I say pick any real number greater than or equal to 0, is 2 a reasonable guess?
Yes.
Yes, it's not a stupid guess. Here, if I say pick any real number greater than 0, greater than or equal to 0, and you say -2. That's not a very smart guess, right? This is, in other words, this is a possibility. So then it does have to be formally excluded. So the domain would be from 0 to 2, non-inclusive, and then union 2 to infinity. Now, you could also draw a picture. Let's go back to this one. So here's 0, and that's what I am allowed to have, and then -2 is out here. Well, this is already on the outside, so there's no need to exclude it. Whereas here, two is inside that region, so it does have to be formally excluded. All right, let me give you one more of these. Let's say again you want to find the domain of h of x is equal to x plus 2 over the square root of x. So here, what's the concern? What's the potential bad thing? We talked about domain. Domain is about not doing bad things, not doing things that are not allowed. So what are the potential bad things? Square root of a negative, right? You can't take square root of a negative. What's the other thing?
X will equal 0.
Division by 0. Okay, so we have to worry about both things. So here, we know again because of the radical that x has to be greater than or equal to 0. But, and you were mentioning this, the denominator itself can't be 0. So in this case, x can't be 0, right? Because the square root of 0 is 0. So then how does that change the domain? What do I have to do? How do I combine these two? What?
Take away the equal to?
Take away the equal to. So the domain is simply x is greater than 0, or 0 to infinity. Right? That's the difference. So if you have a radical in a denominator, you can remember just to set it up, instead of greater than or equal to 0, just set up the radical greater than 0. Because it can't be 0. The radicand, right, what's under the radical is the radicand, can't be 0 in a problem like that. Okay? Questions on any of these? All right, what else? What else do you guys want to go over?
Another one that I couldn't solve with maximums and minimums of quadratic equations, quadratic
All right.
functions.
Let me see it.
I don't think we learned that in my class.
Well, this is actually pretty easy. So you're given a function, g of x is equal to x squared minus 2x plus 3. And we have to determine, there are really three things to talk about. Is there a minimum or a maximum? Where is that minimum or maximum, meaning what's the x value? And then what is the minimum or maximum, meaning the y value? Now, we talked about this earlier. This is a quadratic function. What does the graph of a quadratic function look like?
Parabola.
It's a parabola. So if you have, say, f of x equals ax squared plus bx plus c. If a is greater than 0, if the leading coefficient is positive, what does the graph look like?
It opens upward.
Opens up. If A is negative, then it opens down. So if a parabola opens up, this point here is the vertex, is going to be a minimum. Because it's at the bottom. Right? It's at the bottom of the graph. The vertex is always at the bottom, or it opens down, then the vertex is a maximum. And that's basically it. All right, so for this function, it's quadratic, leading coefficient is positive, so we know there's a maximum. And the maximum is at the vertex. Well, how do we find the vertex? The x-coordinate for the vertex
Negative b over 2.
is h is negative b over 2a. Remember, the vertex is always hk? So in this case, negative b over 2a is negative, then negative 2 over 2 times 1, so you're going to get a positive 1 there. Right? The negatives cancel, 2 divided by 2 is 1. So then f of 1 is 1 squared minus 2 times 1 plus 3 is 1 minus 2 plus 3 is 2. So the maximum is at the point 1, 2. So for the Alex question, it would be the maximum is at 1, and the maximum value is 2. All right? You can say the maximum occurs or the minimum occurs at the x value, and then the minimum or maximum value of the function is the y value. That's all it is. It's about finding. Now, if this were not a parabola, and it were something else, then you can't do that without calculus. It has to be a parabola. That's all you guys have learned. Okay? All right, what else?
Number 3.
Good question. All right, radical equations. In fact, maybe we'll do a more complicated one.
Can you do that one though?
No, I will. I will definitely do this one. So solve the square root of 2x, then plus 4 equals x. So we've got a radical equation. What's the first thing we have to do in a radical equation?
Isolate the radical.
You need to isolate a radical. So that's the 2x, so we're going to subtract the 4 over. So the square root of 2x equals x minus 4.
Square root.
Then what?
Square root.
You have to square both sides. So remember, the square and the square root are inverse operations. They cancel. So you get 2x equals, and you have to square the binomial, and it is not x squared either plus or minus 16. All right, you got to know how to square the binomial. X squared minus 8x plus 16. All right, remember, you can always do x minus 4 squared is x minus 4 times x minus 4, and multiply it out if you're not comfortable with the shortcut. So this is now a quadratic equation, which means everything on one side set it equal to 0. So x squared minus 10x plus 16 is 0. I basically subtracted the 2x and then just flipped it around. This will factor x minus 8 and x minus 2 is 0. Good. So x is
2 and 8.
2 and 8.
But the answer.
But, hold on.
Reject.
But you must, absolutely must check your answers when you have a radical equation, because you can get extraneous solutions. All right, so if we check x is 2, and you have to check it in the original equation. We get the square root of 2 times 2 plus 4 equals 2. So that's the square root of 4 plus 4 is 2, or 2 plus 4 equals 2. And that clearly is incorrect. So then if we check x is equal to 8 was the other solution, we'll see that that works. So we get the square root of 2 times 8 plus 4 equals 8. So this is 16, square root of 16 is 4. So we get 4 plus 4 is 8, which we know is correct. So the solution set is just 8. You have to check the answer. I'm going to borrow this from you here. Okay. All right, you okay with this one now?
Yeah.
All right, now let's do one that's really fun. Solve the square root of x minus 1 equals the square root of x minus 5.
Which number is that?
This is on a separate review, that's not on that review. All right, so notice in this problem we have 2 different radicals, but the procedure is still the same. Isolate one of the radicals, square both sides. Well, we already have one isolated, the square root of x minus 5, so let's leave it. We're going to square both sides. Now here's where things get tricky. So squaring that binomial, if you want to write this out, the square root of x minus 1 squared. And when you distribute, you get the square root of x times the square root of x is x. And you're going to get minus the square root of x twice, so minus 2 square root of x plus 1.
Isn't it 5? Oh, wait, no.
You're on the wrong side. So we get x minus 2 square root of x plus 1 equals x minus 5. So in our first step, we had a radical equation. Then we squared both sides. Now what do we have?
Multiple terms.
No, hold on, not answering my question. We started with a radical equation. How did you know this was a radical equation?
There's a
It
red.
has radical equation. We squared both sides to isolate or to eliminate the radicals. And what did we end up with?
Radical.
Another radical equation. So what do we do?
Isolated.
Isolate the radical and square both sides all over again. But this one's not so bad, because notice if we subtract x from both sides, those are going to cancel. So you end up with negative 2 square root of x equals negative 6, or the square root of x equals 3. Then when you square both sides, you get x is 9. Where did I lose you?
Isn't there a plus 1 there? If you.
I subtracted the 1 over.
Oh, okay.
All right, you got it? You guys good? So now we have to check our answer. So is the square root of 9 then minus 1 equal to the square root of 9 minus 5? Well, this is 3 minus 1 is the square root of 4. So 2 equals 2, that works. So 9 is the solution set. Now this one actually, the algebra was fairly simple. you can get a problem where, say, the x doesn't cancel. And then you end up squaring both sides, so now it becomes quadratic. Right? Kind of like this one did, right? When we squared both sides, it became quadratic. And then we had to solve that quadratic equation. It turns out here, we ended up, after this, we ended up with a linear equation that was very simple. Okay? Any other types of questions you guys have? Any topic, anything you can think of that you want to go over that you struggle with? Yes?
Yeah, domain of one-to-one functions, inverse one-to-one functions.
Okay. All right, I can give you a little shortcut for this one. That's perfectly valid. G of x is equal to x minus 1 over 7x plus 6. So then we're going to have to find G inverse and then the domain and range of G inverse. Now, finding the inverse for this problem is detailed. All right, so what's the first step in finding the inverse for a function?
Switch the x with the y.
Switches, well, write the function as a y. And then switch the x's and the y's. That is correct. Now what?
Multiply both sides by 7y plus 6.
Right? We need to solve for y. So, best way to do that is cross multiply. Or multiply both sides by a common denominator, which would be 7y plus 6. So you get x times 7y plus 6 equals y minus 1. Now in this case, what variable are we solving for? Y. So what's the basic algebra strategy? We talked about this with the exponentials. Everything with a y on one side and everything without a y on another. Now I avoid that phrase, isolate y. The reason being is what students will do is they'll isolate this y. They'll add 1 to both sides, and they'll tell me very incorrectly that y is equal to x times 7y plus 6 plus 1. See, I've isolated y. It's correct. But, do I have a y by itself?
Yeah.
Then I've isolated y. Now, mathematically, this is nonsense. And the way, when I teach something like this, I tell students, think of it as an English class. What is the cardinal sin, the one rule you cannot break when giving the definition of a word?
Use the word.
You cannot use the word you're defining in the definition. Well, that's exactly what I'm doing here. I'm defining y, and I'm using y in that definition. So that's not allowed. All right, so that's why I say get all the y's on one side, everything without a y on another. So what are we going to have to do here on the left-hand side?
Distribute.
Distribute. This is a common. Once you get through a college algebra course, you should be used to this procedure, and you should, because you're going to see it a lot more if you take pre-calculus. So you end up with 7xy plus 6x equals y minus 1. So to get all the y's on one side, what I'm going to do is, I'm going to subtract this y, move it over here, and I'm going to subtract this 6x, and I'm going to move it over there. So that's going to give me 7xy minus y equals negative 1 minus 6x. All right, you with me on that? Now, what's the trick here? How do I get the y?
Take the x out.
No,
I mean,
take
y's-
the y out.
y's
Remember, because I'm solving for y.
Yeah.
So when I factor out the y, what's left?
7x minus
7x minus 1. I can see a lot of students forgetting that 1.
And then you define it.
And then y times something, and we're solving for y. What do we do?
Divide.
Divide by the something. So y is equal to negative 1 minus 6x over 7x minus 1. And that's actually G inverse.
Couldn't you have done, when you did the first part where you put y on the other side, could you have subtracted the 7xy? And
Yes, I
everything
could
would
have
be
moved them
positive?
either way. It wouldn't make a difference.
Everything would have been positive?
If you did it the other way, then you would have had, if you think of multiplying the numerator and denominator by negative 1, you'd have a positive 1, positive 6x, and a negative 7x and a positive 1. Or that could be 1 plus 6x over 1 minus 7x. There's actually there's a pattern. All right, if you look at how you do the algebra, there's a way to go from here to the inverse just like that using the formula. Okay? Now, do you have a question on the algebra or do you have a question on the domain and range?
Yeah, that's what I was.
Okay. Finding the range of a function, particularly these types of functions, is very difficult in a college algebra class. You guys just don't have enough to figure that out. So I'm going to give you a trick. The domain for a function is equal to the range of the inverse, not the opposite. Okay? And the range of f is equal to the domain of the inverse. It's an important fact. Because think about what happens with, right? What's the first step when finding the inverse? You switch the x's and the y's. So the domain becomes the range becomes the domain. Domain and range switch. It's a very important fact to know. How many of you guys plan on going to pre-calculus, trigonometry, calculus? That's a fact that comes up all the time. There are things I can do in a Calc 2 class because I know this fact. Right? Because I know the function, I literally know the inverse function just backwards. So, the domain is the easy thing to find. The range is the hard part. So let's look at our inverse. All right? The domain for the inverse well, to find the domain, we simply look at the denominator. All right? This is what's called a basic rational function of polynomials. So we set the denominator equal to 0 and solve when we get x is 1/7. So the domain is x is not equal to 1/7, or if you want the interval notation, okay? But the range is a lot more complicated. So instead,
Grab the domain and the range.
exactly, the range of G inverse is equal to the domain of the original function G. Now, this is always true, at least until you get to 4,000 level classes. All right, when things get really bizarre, but it'll serve you for at least several years, all right, that this is always true. So we use the denominator of the original function. So we know from here, we want to find out when 7x plus 6 is equal to 0, and that's negative 6/7. So here, the range of the inverse is really, y, you gotta be careful here, because it is a y value, it's a range, is not equal to -6/7, or the interval notation is probably easier to avoid that issue. Negative infinity to -6/7, union -6/7 to infinity. All right, now once you take pre-calculus, you learn there's a way to look at this function, and basically the rule is, if you look at the x's, if the powers of x's are the same, take the ratio of those coefficients. -6 over +7 is -6/7, and that's exactly what you're not allowed to have. Okay? All right. What else? Let me kind of go through this. We've got basic quadratic equations. Vertex, we've talked about that. Center and radius of a circle. You guys okay with that? Symmetry.
Let's do symmetry.
You guys want to go over a symmetry problem? This is number 12.
Oh, you substitute in the.
Right, you've got to substitute in negative x's and negative y's appropriately. All right, so we've got x squared minus 6x plus y squared equals 0. And we need to determine the type of symmetry. Remember, we can have x-axis symmetry. And what do we do for x-axis symmetry?
Substitute in -1.
We change y to -y. And the reason for that is, it really helps to visualize this. If something is symmetric about or over the x-axis, it's flipping over the x-axis. Now what's changing? If I'm flipping up and down, what's changing?
Y value.
The y value. So that's why I change it. So if you have y-axis symmetry, then you change x to -x. And for origin symmetry, then you change both. Now here's a little trick. A graph can have 0 types of symmetry, it can have 1 type of symmetry, or it can have 3 types of symmetry. It can't have just 2 of these. So as you're working it out, let's say the first one, you get symmetry, right? So in other words, if I ask, let's say the question is, how many types of symmetry does this have? The answers are 0, 1, or 3. That's it. Now, which ones you have to find? So let's go ahead and work on just x-axis symmetry. So for x-axis symmetry, we're going to change the y to -y. So that means it's x squared minus 6x plus -y in parentheses squared equals 0. So when I square the -y, I get a positive y squared equals 0. And is that the same equation we started with? Yes, right? It's the same. So that means we do have x-axis symmetry. Now, from here, if I ask you how many types of symmetry does this have, is 0 a correct answer? No. Right, it's already found. 1 could be, or 3 could be. The point here is, how many more of these do I have to test? Let's say I test one and it works. That'll give me 2 types of symmetry. Am I allowed to have just 2 types of symmetry? No. So if a second one works, that means I have to get a third, and I'm going to have all 3. if the next one doesn't work, then it doesn't make sense to try the third one, because the third one can't work, because I can't get 2 as an answer. Right? So if I try y-axis and it doesn't work, that means I can have 1 or 2. Well, 2 is not an answer, I can only have 1. Right? And if you use that fact, it really can make your life a lot simpler with these. So now if we try, did any of your teachers tell you that one? No, they didn't tell you that one? All right, so for y-axis, we're going to plug in the negative x's. So this turns out to positive x squared plus 6x plus y squared equals 0, and that is not the same. Notice that it's not exactly the same. So this one does not work. Either way, I don't have to determine if there is origin symmetry. Okay, so the answer is only x-axis symmetry. The only time you need to determine if there's origin symmetry is if there's neither x-axis symmetry nor y-axis symmetry. So if neither of these work, then there's only one left. The answer of how many could you have is 0 or 1, and both of those are an option. So you still have to test it.
So what if you have y to the third instead of square?
Then you wouldn't have any symmetry. Because if you would have had y to the third here, this would have been a negative. So there would not have been symmetry. If you would have had a y, and then basically, the way it works is you can look at the exponents. I'm guessing that's the question. If you have a mixture of exponents,
You would need that.
even and odd, then you're not going to have any symmetry. If they're all odd, generally then you will have origin symmetry. If they're even, then you will have, as we saw here, you're going to have x-axis symmetry, right? Notice that when I change the y, it's what are those exponents? And all of the y exponents were even. There's only one, it's just 2. Here, the y-axis symmetry didn't work because the exponents on the x's was a mixture of even and odd. So yes, there is that other trick as well. Okay. Distance formula, midpoint formula. You guys okay with that?
All the,
23 and 27, okay? Those are logarithm questions. 23 is a little bit easier. All right, so solve for x. The log of 5x minus 3 minus the log of 2x plus 1 equals the log of 2. Now, one of our goals for this problem, not the final goal, that's important to understand, and not the initial goal, but we eventually want to get rid of those logarithms. Now, there are 2 ways, and 2 ways only, to eliminate logarithms from an equation. You guys know what they are called? Go ahead.
One is divide and the other is change it to e.
Okay, it's not divide. Are you here for the review?
Yeah.
Okay, well, we have about 10 minutes left if you want,
Oh, damn.
if you want to grab a review.
Alright.
By the way, we're being recorded for the internet, so
Oh,
watch the language. You can't divide by a logarithm. Okay? The two methods are what's called the one-to-one property. All right, the one-to-one property says if the log of A equals the log of B, then A equals B. Now the reason why that's called the one-to-one property, actually a couple of different reasons. The main reason is because logarithms are a one-to-one function. They have an inverse, right? Frankly, that's exponential functions. But the other way to think about this is, how many logs are on the left side of the equation? Guys?
Two.
Here, how many logs are on the left side of the equation?
Oh, one.
One, and how many are on the right side of the equation?
One.
Which makes it 1 to 1. Is this 1 to 1? No. So you can't just drop all the logarithms, which is what students tend to do. And that is incorrect. So I need to turn this 2 to 1 equation into 1 to 1. And how do we do that?
Divide.
We turn the subtraction into division. Is that what you meant before?
Yeah.
Okay. Meaning using the properties of the logarithm. So I can turn this subtraction into division. So the log of, or the difference of logarithms becomes the log of a quotient. 5x minus 3 over 2x plus 1 equals the log of 2. I thought you wanted me like to divide by log, which is, I should be able to throw stuff at students whenever they do that. That's really bad. All right. So now I have the log of A equals the log of B. So A equals B. But you got to know this property. You got to know what you're doing. Otherwise, you're just going to write stuff. So what kind of equation is this? Simply, what is this?
It's going to become quad, not quad.
No. What is this?
No, inequality.
Begins with a P. One fraction equals another fraction. It's a proportion. How do we solve a proportion?
Multiply.
Cross multiply. So this becomes 5x minus 3 times 1, we don't need, equals 2 times 2x plus 1. You could have also multiplied through by a common denominator of 2x plus 1. That's the same thing. So we get 5x minus 3 equals 4x plus 2, which gives you x is 5. Then you should check your answer. Generally, when you get these quotients, you're going to be fine. You're not going to get any extraneous solutions, but we should check anyway. When we plug in 5, we get the log of 22 minus the log of 11 equals the log of 2. Now, I don't know what those numbers are, but I know if I put it in this form, I'll get the log of 2 equals the log of 2. And you can always check it on a calculator, so I know that works. Okay, and then on the review,
7.
all right, let me do 25 and then I'll do 27. 25 is another logarithm question. So if we have the log base 2 of x plus 2 plus the log base 2 of x equals 3. Now, this is the other way, this problem involves, the other way to get rid of a logarithm. And that is converting from a logarithm into an exponential. Using what I call it the loop-de-loop. All right, so if the log base b of x equals y, what I do is I start at the base and I draw a little loop. then b to the y equals x. You just follow it around. All right, so a lot of students have trouble how to convert a log into an exponential and vice versa. If you draw the loop, it tells you how to write everything in a loop. And that's what we're going to do here in this problem. And the reason why I know that's what we're going to do is notice that I don't have a log on the other side of the equation. Right? I have multiple logs on one side and a constant on the other. So here I'm going to combine. Again, I need a single logarithm on one side. So this becomes the log base 2 of x times x plus 2 equals 3. Right? The sum of logarithms becomes the log of a product, x times x plus 2. So now I convert into an exponential. So I get 2 to the third equals, and I'm going to multiply here, x squared plus 2x. Just go ahead and distribute that. So that gives me x squared plus 2, I'm sorry, this is 2x. Sorry about that, 2x. X squared plus 2x equals 8, or x squared plus 2x minus 8 equals 0. It's a quadratic equation, so get everything on one side, equal to 0, do the thing. So that gives you x plus 4 times x minus 2 is 0. So we get x is 4, or x is 2. Excuse me, x is negative 4, or x is 2. Now with these problems, you absolutely have to check your answer. Whenever you get a quadratic, you really have to check your answer. Now what we're checking for, more than anything, you can check for correctness if you want to. Really what you're checking for is domain. Are these answers in the domain of the logarithmic functions? So remember, you can only take the log of a positive number. So if I plug in negative 4, I'm going to get the log base 2 of negative 2 plus the log base 2 of negative 4 equals 3. Well, I can't take the log of a negative number. So this is out. I can't do that. So I know that's out. So if I plug in 2, I get the log base 2 of 4 plus the log base 2 of 2. Is that 3? Now, in fact, it is very easily, because the log base 2 of 4 is 2, log base 2 of 2 is 1, and 2 plus 1 is 3. But really, what I'm after here is, are these in the domain? And yes, they are. So 2 is the correct solution. Okay? All right. A word problem about exponential growth and decay. Slow. All right, I guess I'll read it. I'll wait until this loads. The amount of radioactive material in grams present after T days is up. There we go. Could you do me a favor in the back? Could you turn off the light here? Just the front one? No, the other one, please. hope everyone on the internet can read this. All right, so this is number 27. The amount of radioactive material in grams present after T days is given by A of T equals 2000 e to the negative 0.02 T. To the nearest gram, find the amount present after 30 days. All right, so really you've got an input and an output here, right? You've got an x, a domain, in this case a t, and then a y is the value of the function a of t. What does t represent? It's days. Well, what are we measuring in days? Okay, what does t stand for? Just the letter t. Time. T is time. What is a of t?
Amount.
The amount after so much time. Well, what number are we given in this problem?
30.
The days. So what are we going to do?
Divide 30.
No, times.
Well, hold on. We're going to plug. It's a function. We're going to plug in, right? Listen. We only have two things to solve for: the time or the amount. Those are the only two things available to us. So if we're given time, we plug in, because that's our domain, to get the amount. If we were given amount, then that would go here on the left, and then we'd have to solve algebraically to find the time. That's it. Those are the only two possibilities here. So if we have 30 days, and always make sure your units match, days and days. All right, so this is 2000 e to the negative 0.02 t. Let me pull up the calculator. So this is 2000 e to the negative 0.02 times t is 30. So it said to the nearest gram. So to the nearest gram would be 1098. And if we go back to the question,
No, it's not.
then it'd be, in this case, then it would be 1097.
So how you input that on the calculator again? 2000.
Okay, hold on. The answer to your question, how do you put it on the calculator, is directly. What I mean by that is just type it in. So if we were to write this down, and I don't have any room to do that, one moment. If you write down what it looks like, 2000 e to the negative 0.02 times t is 30. Now you don't need the parentheses there. Now depending on your calculator. Now what kind of calculator, go ahead and turn the light back on please. What kind of calculator do you have? Okay, you have a graphing calculator. Depending on how updated your calculator is. Notice when I did mine, now let me pull it back up here. Notice what the exponent looks like. Let me pull up the large screen here. Notice that my exponent looks like an exponent. If you don't have the most updated operating system, then you're going to need to put that in parentheses. So you may have to type in this, 2000 e, and then to the power of, and then put it in parentheses, negative 0.02 times 30. Okay? If you've got a regular scientific calculator, then you're going to work out the exponent first, then you're going to do e to that power, and then you're going to multiply by 2000. So if you have a regular scientific calculator, you're going to do the negative 0.02 times 30. You get negative 0.6. Then you do e to the negative 0.6. and then you multiply that by 2,000. And you get the same answer. All right. Are there any other questions? What about graphing? Any questions on graphing and transformations? No? No other questions on any particular topic?
Would you apply it in natural logarithms or not?
I've already done several natural logarithms. If you have a particular question though. No? What number? 26. This will be the last one, and you should be able to turn the table off. You're welcome. All right, so we have the log base 2 of x minus 2, and you have to graph this. So in order to graph a function, you need to know what the base function looks like. It looks like x squared, and then you do the transformations. So in this case, what does the log base 2 of x look like graphically? Well, you should know that this has a vertical asymptote at x equals 0, an x-intercept at 1, and then basically looks like this. Now you can plot additional points to get more accuracy. We know that when we plug in 1, we're going to get a 0. When we plug in 2, we're going to get 1. When we plug in 4, we're going to get 2, and so on. So now we need to do the transformations. Well, what is the transformation of this going to look like? Up, down, left, right, how many?
Right.
2 to the right. So we're going to take all this information and move it 2 to the right. So that means the vertical asymptote that was at 0 moves 2 steps to the right and is now going to be at x equals 2. The x-intercept that was at 1 is now 2 units to the right, is at 3. And then grab it. All right, but you got to know what the base graph looks like. Now regarding...
So you move the asymptote to...
Yes.
Okay.
Here, the way to think about moving the asymptote is, are you moving it in a different direction than its own orientation? And the way I mean that is, to me, when I graph an asymptote, I think lines on a road. Okay? So let's say you're driving on a road and you've got the lines separating the lanes, right? The dotted lines. If you move those lines 2 units in the same direction they're going, which is say forwards or backwards, or up or down, is that going to change how anyone drives? No. Okay, because everything's still in the same place. But if you take those vertical lines on the road and you move them left or right, that's going to make a big difference in how everyone drives. Not that anyone can drive in South Florida anyways. Okay? All right, so for a vertical asymptote, if you move it left and right, then yes, it's going to move. Also, think of the domain. Right? The big clue here is domain. remember, you can only take the logarithm of a positive number. So for something like this, we know that x has to be greater than 0. That's why the asymptote is at 0, and it goes to the right. But for this one, if you think about what the domain is, we know that x minus 2 is greater than 0, so x is greater than 2. So that's where the asymptote is. It's at 2, and then everything to the right. Yeah.
The intersection on the original graph is at 1x equals 1x.
It's always, yes, it's an x-intercept of 1, no matter what the base of the logarithm is. Base 2, base 3, base e, base 10, doesn't matter. Because the log of any base of 1 is always 0. That's one of the properties of logs. The log of 1, no matter what the base, is always 0. So when you plug in 1, you're going to get 0. So that's the definition of an x-intercept.
Can we do 28?
All right, the last one.
Mm-hmm.
I did a job. All right, so this will be a compound interest question. And I'll write this down for the audience at home. If $2,000 is invested at 6% compounded quarterly, for 3 years, how much will there be at the end? All right? Now, before we work out the math, students, they'll give an answer and not even consider the answer. If you're getting $20 billion, right, that's wrong. If you're investing $2,000 for 3 years and you're getting $20 billion, then you can have all of my money if you can turn 2,000 into 20 billion. If you're getting $972, that's another really bad answer, because you're not going to end up with less than what you started with. Right? The answer needs to make some kind of sense. All right, back to the actual math here. This is a compounded periodic problem. So it's A equals P times 1 plus R over N to the NT. So we're trying to find the final amount. We have the principal. How do we define principal?
The initial
It's what we start with. The initial amount is 2,000 times 1 plus R. What's the interest rate?
6%.
6%. How do we write that?
0.06.
Is 0.06 or 0.06. N is
4.
the number of compounding periods per year. So quarterly is 4. Right? 4 quarters in a whole. To the power of N, which again is 4, times T's the number of years, is 3. Now, the way I recommend that you do this, before you start plugging everything into the calculator, is work out the exponent. 4 times 3 is 12. And if you do that one step first, then, again, depending on your calculator, if you have a graphing calculator or a 2-line display calculator, you can type this in one step from left to right. All right? If you have a regular scientific calculator, then you work out the parentheses, it equals, raise it to the power of 12, and then multiply by 2,000. But if you have a graphing or scientific calculator, you can do this in one step. And you get 2,391. If we want cents, it would be 24 Potentially 23, depending on how you round. All right, but 23.91.24 is the correct answer. Okay. And on that note, thank you everyone for coming, and good luck on your final exams.